Consider, let's just think about the limit as x approaches infinity, and let's think about it in terms of an f of x and a g of x. And we're going to think about f of x and g of x as being equations that are progressively getting bigger, but they're going to get bigger at different rates. So I'm going to pick one that's just, let's say I start off with 1/2 here, okay? I'm just going to write down several different fractions. So this is my first term, so I'm going to say n is equal to 1 here. Well, n equals to 2. Now I'm going to make that 8 over 3. And then I'm going to make this, I guess that ghost didn't like what I had to say, 4, and this will be 64. And so this be 5, and this next numerator, what's 64 cubed? I'm not 64, I'm sorry, 8 cubed. 512. All right, and then next term, 6 in the denominator, and 512 and 8, 16. All right, so I'm going to hold off right there real quick. You see here that in both cases, both g of x and f of x are increasing. How big will f of x eventually get? Infinitely large, right? How big will g of x eventually get? Infinitely large, right? So they're both getting infinitely large. Well, I'm going to take this same expression here, except turn it into g of x over f of x. And again, thinking about the first term, second term, third term, fourth term, fifth term, and so forth. All right, so again, in this case right here, it's the same thing. G of x and f of x just flipped around. Now, what's happening to the overall values of these fractions? Well, 1/2, we can say, yields 0.5. 8/3 would be 2.33. Okay, not very big, right? 64 over 4 is 16. All right, 512 divided by 5 is 100 something. Someone give me a good decimal there for that one.
No, we multiply the bottom. We increase the bottom by 1 and multiply the top by 8.
100 what?
Sorry.
I said you were
102.4.
102.4, okay. And then 4,096 divided by 6.
682.6. Repeating.
All right. So, what's happening? The numerator's growing, the denominator's growing. What's happening to the overall tendency of those terms? They're growing, right? How big will the overall value of those fractions eventually get? Infinitely large. Now, again, we said the same thing's happening here, right? And 2 over 1 yields 2. Now, what about 3 over 8? Say that again.
0.37.
375. Okay. 464, so that's 1/16, so that's 0.0 what?
625.
Huh? 60,
625.
65? All right. And then your 5 over 512.
10033.
And lastly, 4 over 4096.
4.256 times 10 to the negative 4. So 0, 0, 0.
4 what?
2,
2.
5.
We'll stop. Okay.
There. It's supposed to be infinity.
What's wrong?
Is that supposed to be limit as x approaches infinity, or
Yes.
okay?
That's negative infinity or
Thank you.
normal?
Just infinity.
That's still infinity. Still infinity.
It's not gonna go up. It should.
Now again, it's a situation, both the numerator are growing infinitely large, the denominator is growing infinitely large. Yeah, go ahead.
What are the ends under the fractions for?
That's just the number of term we're on. This is the first term, the second term, the third term, the fourth term, so forth.
How do we know it's like that? Like, how do we know it's these numbers?
Say that again.
Like, how do we know it's these numbers? Like, why are we multiplied by 8?
Because I wanted to.
Okay. That's fine. I just wanted to.
Okay. The question was asked, why in the numerator am I adding 1, and why in the denominator am I multiplying by 8? I was just trying to illustrate. This comes from no particular problem. I was just trying to illustrate a scenario where you had both numerators and denominators growing just at different rates, and how that can affect. So the overall tendency of this problem is the limit as x approaches infinity of f of x over g of x, in this case, was infinity. But what's happening here is we've got g of x over f of x this time.
0, 0.
It's getting closer and closer to 0. So, a few different things can happen here. We can also, and we'll look at one in just a minute, where we're going to actually approach a constant number besides 0. But for right now, we're going to keep considering this. So, essentially what's happening is the limit as x approaches infinity of f of x over g of x is equal to infinity if the numerator grows at a faster rate than the denominator. The limit as x approaches infinity of g of, well, let's just say g. It doesn't have to go with this scenario here. If x over g of x is equal to 0 if the denominator grows at a faster rate. And I should, I guess, throw in that this is not a linear faster rate. We're going to look at linear in just a second here. Now, for polynomials, which is what we're going to be dealing with mostly, we compare the degree of the numerator of of the denominator. If, again, the numerator grows, or if the numerator has a larger degree, let's say, then the limit as x approaches infinity is infinity. Likewise, if the denominator has a larger degree, then the limit as x approaches infinity is 0. And we looked at that not really with well, I guess that numerator could have been 8, just x plus 1 over 8 times x minus 1. I don't know. So, anyway. What happens when they're the same? We talked about the degree of the numerator is larger, it's infinity. If the degree of the denominator is larger, it's 0. Let's look at when they're the same. So let's just take an example of 8x squared minus 3x plus 2 over 6x squared minus 1. Okay? Now, the numerator has more x's in it. But what we're going to end up seeing is that as we do this, these terms out here are going to matter less and less. So if this is f of x, if f of x is 8x squared minus 3x plus 2, and it's over 6x squared minus 1, then what is f of 1? And I'm going to call them different rows. Yeah, I want y'all to solve f of 1. What now?
You said us to solve.
Yeah, just your row. The 4 of y'all go with f of 10. Y'all do f of 100. Y'all do f of 1,000. Y'all do f of 10,000. But we're going to do it a little bit different. Don't just plug that into your calculator. Because we're going to get numbers, but we want to see kind of where these numbers come from. So what I want you to do is to break, like I'll do f of 100. I want y'all to break it down into 8 times 100 squared minus 3 times 100 plus 2. And then 6 times 100 squared, and then minus 1. And this is going to give us a little bit better picture of why the behavior is doing what it's doing. Sorry, I know that's in your way.
No, it's okay.
We got a few people out today, so can you move that for just a second? Thank you.
I'm sorry, I was looking.
You're good. You're good. You're good. You're good. You're good. You're good.
She's gonna be the nicotine. Her food. I mean, I thought we went through it yesterday, would die because like that was an insane amount. Yeah, we moved it that amount. We moved it down to 7 The one that we did like the one, that was also a lot. That one died too. Yeah, all of them. So all of them that had nicotine died. Wait, the nicotine that we bought, or the nicotine that Officer actually that was THC. They're still alive. The THC ones are still alive. That was only one. Okay, that makes more sense. That's a good amount. I don't think we got very right, exactly. So they're trying to regenerate, and if they already don't have a lot of, they're very fragile. I think they use just their yeah. But we are testing their regenerative ability. Yeah. So it makes sense.
All right. So I've got everything semi-written out here. So first row, y'all have the tough one. 8 minus 3 plus 1, I'm sorry, plus 2 is what?
7.
And then, don't get ahead. Always trying to outdo Claire. So it's 7 over 5. All right. Now, who had F of?
772 over 599.
707. All right. So it was 800
Minus 30 plus 2.
minus 30 over 600 minus 1. And this was what did you say again?
772 over 599.
Over 599. All right. Everybody fine with this? Okay. Okay. So this is 8 what? 80,000 minus 300 plus 2. All over.
60,000 minus 1.
All right. So you've got your 80,000 minus your 300. That is what?
79,700.
And then plus 2.
79,702.
79,702.
Over 59,999.
Yes.
All right. Now, again, breaking this down, 8 million, right? Okay. Minus what? 3,000. And then plus 2.
Yep.
I did the hard part for you. Okay. So the 8 million minus 3,000 is
7,997.
I want to add 2 in just a second. You'll see why. So just the 8 million minus the 3,000 is what? 97,000 over, oh, then it's plus 2. And then that's just going to be 5,999,999, which, as you said, is 7997002. All right. And last of all, Will, did you give up? All right. This is 8 with 8 zeros. minus 30,000 plus 2 over 6 all right. I think it's safe to say that one in the denominator really doesn't make a difference. And the bigger we get, I think you're going to see that the 3 in the numerator doesn't really make a big difference, and definitely the 2 in the numerator doesn't make a big difference. So this would be 799. How many nines do I need? 4? Is that right? Wow. Over. That, right? Got too many nines in here. I went 9 happy. Okay. That is a technical math term. To go 9 happy. All right, that was lame. But, I mean, what happened here essentially? I started putting 9s in here and 0s in here, and just increasing that gap even more. But overall, what is 7 over 5 as a fraction, approximately?
1.4.
Say that again?
1.4.
1.4. Okay, that's not even approximate. That's equal, right? All right. What is 772 over 599?
1.28.
Say that again?
1.28.
Let's go 4 decimals.
8.
8, 9. Okay.
No, just 8.
4 decimals.
1.3283.
Okay.
Um, 1.3328.
Probably had to be careful putting that one in, because it would probably run off the screen.
1.3333.
How far out do? Let's take this one out all the way. So it's 1 point.
It's 1.333283339.
All right. So, what do you feel like just looking at what's on the board? What does it feel like that limit's getting to as that x value gets larger and larger and larger? 1.333, right? Which is essentially 4/3, right? Does anybody else see the number 4/3 on the board anywhere? 8 over 6. You take your leading coefficient, and the ratio formed by those leading coefficients is 4/3. That's ballin'. Very ballin'.
Is that like the asymptote or something?
Say that again.
Isn't like to get like a certain asymptote?
It's going to be a horizontal asymptote, yes. We're going to have a horizontal asymptote here. So my horizontal asymptote is going to be y equals 4/3. In this problem right here, my horizontal asymptote was y equals 0. For those of you watching this virally at home, that was what I was pointing to, right? I think I'm still off the board. Yeah, there we go. So y equals 0 right here. So anyway, any question about that so far? So what we're seeing, and that's the reason I was trying to illustrate the fact that I was wanting us to see what was happening when we were physically subtracting 3,000 from it. When we're physically subtracting 3,000 from it, or when we're physically subtracting 30,000 from this number, that this number becomes less and less significant, all the way down to the point where we were in the 10,000ths place right here. And we weren't even off by much then, because if we rounded the 8, it would make the 2 become a 3. So that is what is going on in these problems here. So y is equal to 4/3. So let's talk now about what happens when that numerator's degree is greater than the denominator's, kind of like in the scenario right here. Well, let's take y equals 8x squared minus 3x plus 2, and let's put that over not 6x squared minus 1, but just 6x minus 1. And I'm going to erase the rest of the board. Well, again, that numerator is going to grow a whole lot faster than the denominator. And this is where we look to something called a slant asymptote, also known as an oblique asymptote. Now, if that's the scenario here, then what I'm going to do to try to figure out what that asymptote is I'm going to see, well, what is this if I divide this out? This is going to give me what my what my slant asymptote is. So I'm going to have 6x minus 1, and I should not have made up this problem because it's going to get ugly. 8x squared minus 3x plus 2. And I want to know what the slant asymptote is here. Well, to do long division, 6x times what gives me 8x squared? Four-thirds x. So this is going to be times 4/3 x. All right, so 4/3 x times -1 is, that's tough, it's fraction multiplication. I'm joking, it's not tough. What is it? It's multiplying by 1. -4/3 x. Okay. And then 4/3 times 6. 3 goes into 6. And 2 times 4 is 8. So I get 8x squared. The number I get here better match that number right there. All right, now, again, long division, when you do division here, the next step is to subtract. If you're subtracting polynomials, you're really distributing the negative into this polynomial and adding them together. So this is going to be minus and this is going to be plus. So I've got -3x, which is the same thing as -9/3 x. What's -9/3 x plus 4/3 x? -5/3 x. Then I pull out my plus 2. All right. So 6 times what gives me 5/3? It's going to be 18 over -5, so -18/5. Yeah, I shouldn't have made up the problem. So I get -18/5 here. Now, I can really stop here. Because at this point, I don't need to figure out what my remainder is. This is my line. This is my slant asymptote. Y equals 4/3 x minus 18 fifths. And I'm gonna pause the video for a second.